There are a number of similarities between oxidizing agents and reducing agents and Bronsted-Lowry acids and bases. Bronsted-Lowry acids and bases pass hydrogen ions back and forth, whereas oxidizing agents and reducing agents pass electrons back and forth. A Bronsted-Lowry acid and its conjugate base are the same species with and without a hydrogen ion, whereas a reducing agent and its complementary, we don't say conjugate, its complementary oxidizing agent are the same species with and without an electron. Amphiprotic species can donate and accept hydrogen ions, whereas multivalent transition metals have ions that can both be further oxidized or reduced. The stronger an acid, the weaker its conjugate base. The stronger a reducing agent, the weaker its complementary oxidizing agent. So in other words, if a species has a strong tendency to give its electrons away, it will have a weaker tendency to take those electrons back. So take fluorine, for example, which is a strong oxidizing agent. It really wants to gain electrons. It wants to oxidize something else so it can gain electrons and form fluoride ions. That way, each fluoride ion has a full octet, which is a better situation rather than being in a diatomic covalent bond where it's sharing its electrons. So fluorine really wants to gain electrons by oxidizing something else to form fluoride ions. Fluoride ions, on the other hand, are perfectly happy with their full octet. They really don't want to give up their electrons. So that's why fluoride ion is a very weak reducing agent. So there's this relationship between the complementary reducing agent and oxidizing agent.